Exercise 4G, question number 9. Given that probability of A is 0.42, probability of B is 0.37, and probability of A intersection B is 0.12. Let's start by making the Venn diagram for this information. We have sets A and B. So A and B, we are given that the intersection is 0.12, therefore we can write 0.12 here. Then we have probability of A as 0.42. Probability of A is the entire circle of A. So we can find out the probability of only A, which is this region, by subtracting from 0.42 0.12, and that will give us 0.3. Similarly, we are given the probability of B, which is 0.37, which is for the entire circle of B. We can find the probability of only B by subtracting 0.12 from 0.37, and we get 0.25. Now we can find the probability outside both the circles. We know that the probability in a Venn diagram adds to 1. So if we add up all the probabilities inside the two circles and subtract from 1, we can find the probability outside the two circles. So we do 1 minus 0.3 plus 0.12 plus 0.25, and we get 0.33. So outside the two circles is 0.33. Now we can answer the questions A and B. Question A is find probability of A union B. So A union B is all of A and all of B, but without any repetition. So we can see that the part here is being repeated, 0.12, as it is a part of A and B as well. So we will not repeat it twice, we will take it only once, and hence A union B is going to be 0.3 plus 0.12 plus 0.25, and that adds up to 0.67. Question B, find the probability of A given B complement. Now this is a question that is related to conditional probability. So in conditional probability, our domain is reduced to this B complement, which means we have to take the probability from B complement. Now B complement is everything outside B. So we will take B and look everything outside of B, because that is what we are looking at. Everything outside B is 0.3 and 0.33. So that is our total from which we need to pick up A. So we have 0.3 and 0.33 as our total, which is our denominator, and we need to find A from it, so 0.3. So the probability is 0.3 divided by the total probability of B complement, which is 0.3 plus 0.33. And this also can be done by formula. If we understand that A given B complement is the same as A intersection B complement divided by B complement. So we can use this formula and get the same result, and once we simplify, we get 10 upon 21, and that equals 0.476. That answers for part B. Now in part C, we have the event C adding up. So since we have another event adding up, we have to draw another diagram as our probabilities will change here. So we'll draw another Venn diagram with 3 circles as we have A, B and C. But before we draw, the question says events B and C are mutually exclusive. So when B and C are mutually exclusive, that means they do not intersect. So let's draw C here and B here, so they do not intersect. And A and C are independent, so let's draw the circle A also. Alright, so we have A, B and C, and B and C are mutually exclusive. So now the probability of the set C is 0.3, and we need to find the probability of A intersection C. So we already know the probability of A, and we already know the probability of C. Therefore, probability of A intersection C is probability of A multiplied by the probability of C, and that is 0.42 multiplied by probability of C, which is 0.3, and we get 0.126. So let's fill up the values. A and C intersection is 0.126, and we have B. A intersection B is already given here in the first part of the question, which is 0.12. So let's fill that, 0.12. We can fill up the remaining probabilities as we know the probabilities of A, B and C. So probability of A is 0.42. Therefore, to find the probability of the only A part, which is this one, we can subtract from 0.42, 0.126 and 0.12 and find the probability of only A, which is 0.174. Similarly, we can find the probability of only B, which is this part, by taking the probability of B, which is 0.37, and subtracting 0.12. So we get the probability of only B part, which is 0.25. And for C, we have the probability of C as 0.3, which is for the entire circle. We can subtract 0.126 from 0.3 to find the probability of only C, which is this part. So when we subtract, we get 0.174. We also know that the total probability in a Venn diagram adds up to 1. So if we add up all the known probabilities and subtract from 1, we can find the probability which is outside all the 3 circles. So when we do that, we get the value outside all the 3 circles as 0.156. So that answers to filling up the Venn diagram. Now that was part D, and for part E, the question says find the probability of A complement union C and the complement of that. So let's first find the probability of A complement union C. So A complement union C, which means everything outside A. So let's take everything outside A, which will be A complement. I'm highlighting it so that it is well visible. So this is A complement. And we have to take union of this with the circle C. A portion of the circle C is already highlighted when we have taken A complement, Now we have to take C also. So we will highlight this region. So that is A complement union C. And now A complement union C, we can add up all the probabilities and find that is 0.174 plus 0.126 plus 0.25 plus 0.156, and that equals to 0.706. But we want the complement of this, which means we need to subtract from 1 0.706, because we want the complement of the yellow highlighted area, which means we do not want the yellow highlighted area. So when we do 1 minus 0.706, we get 0.294, or otherwise we could have found the answer directly by adding 0.174 and 0.12, which would give us 0.94.